There is something in the human mind that has never learned to accept a horizon as a final answer. Give our species a wall, and within a generation, someone is building a ladder. Confront us with the limits of physical strength, and we build machines. Block our access to the sky, and we invent flight. For as long as we have existed, the stars have been the ultimate horizon, glittering with an authority that calls to us across history. But when you look up tonight, you're experiencing one of the most consequential illusions in human history. Because the stars look reachable, as if they're resting on a comprehensible dome just above the mountains. This illusion persists because our eyes and brains evolved to process distances measured in feet and miles, the scales relevant for spotting predators or finding water. The universe, however, operates at scales so far beyond our evolutionary experience that our intuitive distance machinery simply has no valid reference frame. Tonight, we're going to follow the physics all the way to a wall that no amount of human ambition can climb. We're going to talk about why the void between us and the nearest sun is not just a gap to be bridged, but a structural limit of reality. To understand why the stars are probably outreach, we have to start with the arithmetic of distance. The closest star to our sun is Proxima Centauri, located 4.2 light-years away. That's approximately 25 trillion miles. If you were to walk there at a comfortable pace, it would take you 950 billion years. You would have needed to start your journey 69 times before the universe even existed. Even a modern jet aircraft traveling at 570 miles per hour would take 5 billion years, the entire lifespan of the Earth and Sun so far, just to reach that one nearby neighbor. Our fastest spacecraft, Voyager 1, is currently screaming through the dark at 38,000 miles per hour. At that speed, the journey to the nearest sun would take over 75,000 years. Human agriculture only began 12,000 years ago. A journey to our closest neighbor at current speeds would span a time frame longer than all of recorded human history. On this scale, Proxima Centauri is another grapefruit located 1,500 miles away. That's the distance from New York to Dallas. The void between stars is not merely large, it is structurally dominant, dwarfing everything within our solar system so completely that stars are almost negligible details scattered across an overwhelming emptiness. In 1905, a 26-year-old patent clerk named Albert Einstein introduced a hard speed limit embedded in the fabric of reality itself. This is not a technological barrier that we might break in the future. It is a structural feature of how the universe is built. As an object's velocity approaches the speed of light, something called the Lorentz factor kicks in. At low speeds, we don't notice it, but as you push toward light speed, the energy required to accelerate begins to diverge toward infinity. Mathematically, formally, and provably, no finite energy input can accelerate an object with mass to the speed of light. Let's look at what this means for a spacecraft weighing 1,000 tons, roughly twice the mass of the International Space Station. To reach just 10% of light speed, your ship would need a kinetic energy of 4.5 times 10 to the 20th joules. That is more energy than the entire nuclear arsenal of every nation on Earth detonated simultaneously. And here's the tyranny in action. As you move faster, the ship effectively becomes heavier and harder to push. At 90% of light speed, the effective inertial mass of the spacecraft is more than double its rest mass. At 99.9%, it's 22 times heavier. The universe actively resists your ambition, demanding exponentially more energy for every additional fraction of a percent of speed gained. Even if we could find the energy, we have to carry it with us. This is where we meet the Tsiolkovsky rocket equation. It describes a logarithmic relationship that is the source of enormous pain for interstellar mission designers.
The equation tells us that to increase your velocity, you must carry propellant to move your payload, but you also have to carry propellant to move the propellant you haven't burned yet. This creates a feedback spiral that rapidly produces absurd mass ratios. If we used the best chemical rockets we have today to reach just 10% of light speed, we would need more fuel than there are atoms in the observable universe. Even if we used nuclear fusion, the power that lights the stars, the math remains brutal. Project Daedalus, a rigorous 1970s engineering study, designed a fusion-powered probe for a one-way trip to a nearby star. To get a tiny payload to 12% of light speed, the ship had to be 54,000 metric tons at launch. Over 99% of that mass was nothing but engine and fuel. It required 30,000 tons of helium-3, a fuel so rare on Earth that we would have to mine the atmosphere of Jupiter just to get enough for one unmanned flight. And that's just to reach the star. If you want to stop when you get there, you have to carry a second mountain of fuel to slow down, which then requires a third mountain of fuel to accelerate that deceleration fuel in the first place. The ratios compound until they become a mathematics of despair. Even if we solve the energy and fuel problems, the void itself becomes a lethal weapon at high speeds. Space is not truly empty. It is filled with hydrogen atoms and dust grains. At 10% of light speed, these atoms strike the front of your ship like projectiles from a particle accelerator. A single grain of dust hitting your ship at relativistic speeds releases energy equivalent to a hand grenade. The interstellar medium effectively becomes a sandblaster, shredding your hull and bombarding your crew with lethal radiation. To survive, you need meters of heavy shielding, which adds more mass, which requires more fuel, which starts the rocket equation spiral all over again. This is the harsh reality of our universe. Interstellar travel for humans, in any practical, fast, and reversible sense, is probably not achievable. The physics is too unforgiving, the scales are too vast. But perhaps there is something profound in this isolation. If the galaxy is not a place where we can easily hop from star to star, then Earth is not a stepping stone, it's home, the only home we'll likely ever know. The solar system is our entire estate, and it's full of resources and wonders that are actually reachable. The laws of physics that trap us are the same laws that make the universe comprehensible. We can understand a star 700 light years away, even if we can never touch it. Our minds can reach farther than our ships ever will. The stars are beautiful because they are distant, reminding us of the vastness beyond, even as we build our lives here. We are a way for the universe to know itself, and perhaps the real journey was never about crossing the miles, but about the depth of our understanding. Thank you for joining me on this journey through the limits of our reality. If you found this exploration valuable, consider subscribing to stay inside the discovery as it unfolds. Keep looking up and make your time in this warm bubble count. Good night.